Hello, and welcome to another Math with Taebyn. My name is Taebyn. I'm a pup, bark, and I just learned a new word, mowiki tick. It means go fast, I guess. Anyway, that's not what this video is about, though. This video is about something called the Cantor Set. So the Cantor Set is a thing that was discovered by Henry John Stephen Smith. That's not four people. That's actually one person. Looks like four names, but no. In 1874. Yes, 1874. But it wasn't worked with and actually brought to people's attention until 1883 by Georg. You actually pronounce that Georg Cantor. I think I spelled that right. If I didn't, leave the comment in the comments below, and I'll say thank you. The Cantor Set. Let me tell you what it is. You start with a unit interval. So what do I mean by the unit interval? Really quick. Well, you have to. So here's the real line, like all of the numbers. You've got 0, and you've got 1, 2, so on and so forth. Got negative numbers. The unit interval is just the numbers from 0 up to 1. So here's squeaky. Okay, so from the unit interval, I want to show you how you create the Cantor Set. Okay, so here's 0 and 1. Okay, so there's a unit interval. So what I'm going to do, this is an iterative process. There's going to be multiple steps, but you do the same thing at each step. So you start by removing the middle third. So here's like 1/3, if I had to put numbers on it. So here's the middle third, and I remove it, erasing the middle third. Take that out. Okay. Now, you take each of the little intervals that's left, and you do the same thing. Remove the middle thirds. So here's this middle third. So, by the way, the open middle thirds just meaning so that you keep this like 1/3 and 2/3 ends, and you take this middle third out. And then you take this middle third out. So what does that look like? And if I had to put numbers on this, this would be 1/9. This would be 2/9. And this would be 7/9. Sorry for my bad pausey writing, because I'm a pup and I don't write things well. So you remove those middle thirds. If you can see that. Yeah. Okay. Oh, that didn't erase. There. Okay. So you're left with that. Let me get these numbers out of the way because they're in the way. And then you keep doing that. So you take away the middle third of each thing that's left. That. And then remove the middle third of everything that's left there. And then keep doing this forever. Well, don't do it forever because you might get bored. But ideally, you do this forever, and what you're left with is something called the Cantor Set. So you can imagine you get like this dust, like all these little tiny particle pieces. And this thing has really interesting properties. It's a fractal, for one, and a fractal just means that it's self-similar, basically. So which means that in the Cantor Set, you take any piece of it, and it looks like itself anywhere else. That's what it means to be self-similar. It's because of that, it is a fractal. What's the dimension? Well, it turns out it's 0-dimensional. 0-dimensional. Let me write that down. 0-dimensional. And it's a fractal. Fuzzies. 0-dimensional. And it contains no interval, contains no intervals, and what I mean by that is that there's no like actual little length pieces in there. It's all just little dots scattered around in kind of there's a pattern to it, but they're just scattered through there. Contains no intervals. How big is it? Like, what's its length? Well, it's not really a length, but the mathy term is measure. So what's its measure? It turns out that it has measure 0. Measure. So it has no measure, but there it is. And it's 0-dimensional, contains no intervals, but it's a thing that's there. So that's very interesting. Now, let me show you another equivalent way to think of this thing. So if you take this, here's my unit interval, and then the next step would be, what does it look like? It looks like this and this, right? And then keep going, then the next step would be like this. And again, you're doing this forever, and in the end, that's the Cantor set. Now, what you can do is label these. Like you can label this the number 0 and this the number 2, right? Because if you were to think there's 3 parts to the interval, 0, 1, and 2, I'll just label the parts that are left. And do that down here. 0, 2, 0, 2. And keep going, 0, 2, 0, 2. So you're just labeling each little part. Now, if you want to know what numbers are left in the Cantor set, well, you take it back to this original picture I drew, the number 1/3, 2/3, 1/9, those are in there. But you can also easily, quote unquote, easily find what other numbers are in there. So you could imagine take a ball and just let it go, and it follows a path. And so you could write this out like as a decimal. So you have the decimal 0, 2, 0, then wherever else it goes. Forever, never, never. This decimal number, there are mathematical ways to turn it and see what it is in fraction, but whatever it is, this number is a number in the Cantor set. And because of this, notice that any number in the Cantor set in this what's called ternary decimal expansion doesn't have a 1. And that classifies exactly what numbers are in the Cantor set. So that's really cool and interesting. Now there are 2- and 3-dimensional analogs to this thing. Here's a picture of the 2-dimensional analog. And here's a picture of the 3-dimensional analog. And these things are actually called Cantor dust. And they're very interesting. And it's something that's easy to produce, but you can do a lot of interesting things with it. There's a thing called the Cantor function, which is really cool. And maybe I'll do it in another video sometime. But a Cantor function is basically, there's a way to build a function off of the Cantor set. And really cool properties of this function are that it's increasing, it's continuous, but it's flat, quote unquote, almost everywhere. So like it's almost everywhere it's flat, but you're still getting from 0 all the way up to 1 in a continuous way. It's really cool and interesting. Anyway, that is what I wanted to tell you about the Cantor set. I hope you learned a lot. I hope you enjoyed it. If you have any questions, leave them in the comments below. Until next time, I say, move, bark, fluff, stay furry, bark, bark.